Hello technophobes and welcome to Cloning 101, or as we like to call it in Year 10 Science, B1 Section 6.5. Oh, look at my old dog. She's a good old dog, but she's getting a bit old and I don't really want to be lonely, so I'm going to make a clone of her. Now to get a clone, I'm going to need to use her genetic information to make an almost exact copy, genetically the same. So first I just need to somehow extract one of her skin cells. Oh, that's looking good. There we go, look. So we can see the genes there of good old Blue. You have a rest, old girl. You're getting a bit tired. You just sit over there. So I've got, in the nucleus, you can see all of her genetic information tied up in the chromosomes. So the chromosomes are made of a chemical called DNA, or deoxyribonucleic acid, sectioned up into small bits called genes, which code for all of the things like, come back girl, there you are, code for her golden skin, her beautiful wet nose, her legs, her arms, all of the features that she has. So there you go, you have a wee rest, love. I'm also going to need an unfertilized egg cell from a separate dog, so you ain't going to enjoy this, honey. Hey, let's get that cell out. Oh, I think I've got it. There we go, look at that. Okay, you can definitely have a rest. Dog pound. You can see here that we have only half the number of chromosomes because it's an unfertilized egg. So what I'm going to do now is, this is the hard part, I'm afraid, folks. I'm going to extract the nucleus out of this unfertilized ovum. Oh, I think I've got it. Excellent. So now I have an undifferentiated cell which has all of the machinery in place to make any kind of cell in an older dog. But what I'm going to need to do is get the genetic information from you. Sit girl, shh. It's tricky this bit. Extracting the nucleus from the adult cell and implanting it into the unfertilized egg. So now I have all of the genetic information from my dog in an egg of a completely separate dog, but it's no longer an unfertilized egg as such because it's got all of the adult, it's got the full complement of chromosomes in there. So I need another dog now. Well, actually, no, before I need another dog, I'm just going to give, let's get rid of that cell, don't need that anymore. I'm just going to give it a slight little electric shock to this fertilized egg. Let's go. Oh, that's good. Right. Just a mild electric shock to stimulate it into dividing and growing. So we'll just get out of focus a little bit. Oh, there we can see. So it's dividing. Come back another day for the dividing clip. That ain't going to be today. Oh, hang on. Getting a bit more interesting here. Oh, we've doubled up. Good. Again, doubling up through mitosis. Go from 2 to 4 cells. You can see the embryo getting larger and larger. The cells are still undifferentiated, so they will grow into whatever we want. Well, that's a pretty good looking embryo. I think it's time that we implant this embryo into another dog for the host. So let's just get that embryo. Close your eyes, honey, it's going to be cold. Gee! Now, that dog is now pregnant, and the embryo it has contains none of its genetic information, but it will eventually give birth to another dog which has the genetic information of my dog. That's a good girl, you sit down. Oh, here we go, I think it's time. I can see just about to give birth. Oh, look, a little clone of my dog. So it's now a clone containing exactly the same genetic information as my dog. Let's just pull out one of his skin cells. Yeah. Oh, so we can see that genetically it's identical to my dog. I'll just bring that cell back into focus here. Come here. The genes are identical, so the genetic information is the same. Of course, environmental things like how much I feed my new puppy will affect its final appearance. Now, just to confirm, I'm going to take a skin cell out of the donor dog here and we'll see what its genes look like. Oh, this might be a bit scary. It's one big dog. So if I take them out, there we go. So the genes are different. My original dog with her genes, my new clone with identical genes. Donor dog with a different set of genetic material. And there you have cloning.